Okay, how'd you do on the first one? Did you get the first one, do you think? Actually, I can answer this question right now. Because what do I know about the range of the inverse? It's the domain of the original. So what can you tell me about the domain of the original? X can't be 0. So if the domain of the original is x can't be 0, then the range of the inverse will be y can't be 0? Let's see if that pans out. Let's go ahead and find our inverse. Okay, so I'm going to go through. I know some of you have found like little shortcut things, and that's all right, except you'll probably forget them. So I'm just going to go ahead and work through the problem. So I'll substitute in a y here. And then what do I do? Switch my variables. And then what do I do? Get rid of the fraction. In the process now of solving for y. So once I get rid of the fraction, I'll make sure everything with a y is on one side. Because once I get everything with a y on one side, what can I do? I can take it out, factor it out, and then I will divide. So is that what you got for your inverse? -5 over 3x minus 8? All right, now let's talk about the range of this. Let's suppose you did this part first, which you could. What would the range of this be? Now remember, when we're dealing with things that are like reciprocal functions, the range is all about where the asymptote is. Where's the horizontal asymptote in that problem? At 0. Why? There's not an x on the top. There's more x's in the bottom than there are in the top, and whenever that happens, your asymptote is at 0. Okay? Yeah.
So will the range always be the domain of the original?
Yes.
So, but then you have to check it as well?
No, you don't have to check it. I'm just trying to make that connection for you. I knew this was the answer.
Okay.
Because the range of the inverse will be the domain of the original. Because what did we do to find the inverse? Switch order pairs. So what was x is now y. All right, did you understand what you were supposed to do here? Okay, how many equations is this? 2. And we have a parameter in there, right? We have a t in there. We want to remove that parameter and write one equation. So what was your thought? A couple different strategies I can see here. What did you think to do?
Solve for t.
In which equation?
The y one.
So you said t equals y over 3?
Yeah.
And then?
And then I plugged it in for the t on the thing.
So you had x equals the square root of y over 3?
Mm-hmm.
And did you do anything with that, or did you do it like that, or what did you do?
I solved for y then.
So how did you do that?
I square rooted both sides.
Square both sides. So you had x squared equals y over 3.
And then multiply it by
So y equals 3y squared? Y equals 3x squared?
Yeah.
Anybody want to agree, disagree? See some nodding going on. Anybody have a different strategy? That strategy's fine. Anybody have a different one? Matt?
I squared the x on x equals.
So from the beginning, solved for t in this equation, and then substituted that right here, and look at the end result. It's exactly the same. Good job. Either one's fine. Okay, we all right with that? Okay, then we've got our transformations. I turned back yesterday's little group quiz. That was out of 5. I think there's a few things we still need to review. So let me draw this picture over here so it's on the video. All right, this is our original picture that we are dealing with. All right, did you have a thought about this one? Is that plus or minus? Plus?
Close.
Did you have a thought about that? What did you do to this picture to get this? What'd you do? Lily?
Move everything up.
Yeah, we now have two Lilies. You took this picture and picked it up 1 unit. So instead of the circle, little circle thing, bottoming out at -1, it bottoms out at 0 like that. And the little trapezoid thing looks like that. Everybody good with that transformation? All right, the next one was a negative. Okay, now what do negatives do? Pluses and minuses shift your picture. Pick it up and move it around. What do negatives do? Lily? Other Lily?
Flips and it's across the y-axis.
This is a reflection, and she's right, it goes across the y-axis. So, Sarah, you okay?
Yeah.
So we flip across the y-axis. So in other words, back to the original, what was on the left is now on the right. And what was on the right is now on the left. Anybody have an issue with that? Okay, what about, oh, the next one I got a little tricky on. I'm going to do this one in 2 steps because it's just too much for me. You don't have to do it in 2 steps. You can do it in 1 if you want. What would have to happen first? Think of your regular order of operations, kids. We start in parentheses first. So the first thing we're going to do is take care of this business right here. What does x minus 2 do? Inside the parentheses, x minus 2. Bailey? Moves it to the right too. So I'm going to take my original picture and I'm going to move it to the right 2 units. So this little guy is going to get shifted over here. So is everybody okay? That's step 1. Is everybody okay with shifting to the right? Now, absolute value of the whole thing. When you take the absolute value of the y values, what happens, Dan?
That makes the thing positive at the bottom of the positive.
Exactly. If it's already positive, it's fine, it stays. But this part gets bubbled up. There is your answer. When you take the absolute value of f of x is y. You're taking the absolute value of the y's. That means you're making the y's positive. Right? Okay, and one more. What does, you know what, I'm going to go ahead and, that wasn't in the original. I'm sticking that in there though, so we get some practice with that too. So I'm sticking that in. I'm changing the problem, sorry. All right, let's talk about these multipliers. Negatives reflect, right? Adds and subtracts shift you. What do these coefficients do? Mahela?
The first one in front makes it half as tall.
So this is a vertical change, right? Stretch or shrink. In this case, shrink, because it's a half. So we're going to have that picture, but it's going to be half as tall. Okay? What does this one do, Mahela? Do you remember?
That's twice as long.
It's going to make, it's a horizontal change, And it's the opposite of what it says. It says take half, it's really double. Okay? So we're gonna have that picture twice as long and half as tall. Let me say that again. Twice as long and half as tall. So that little circle right there is going to be half as tall but twice as long. So instead of being 2 units wide, it's going to be 4 units wide, right? And our trapezoid, instead of being 2 units tall, it's only going to be 1 unit tall, but it's going to be twice as long. So instead of being 3 units wide, it's going to be 6 units wide. Okay? Now, while we're still kind of in this mode, let's look at your quiz. And we need to do problem number 1 was the one that was missed by, if you missed something, a lot of you missed number 1. So let's talk about that for a minute. Okay, so here was the original picture. I think it helps to have it on graph paper, doesn't it? Okay, there's the original picture. And you were to sketch this, right? Yeah. Okay? I tried to explain this, and I guess I didn't do a very good job. Can somebody tell me what's going to happen here? What happens when you take the absolute value of just x? Dan?
You just use all the positive x's and put it on the other side.
Well, yeah, all the positive. You're taking the absolute value of x. So if you have a positive x, nothing is changing. These are the positive x's. Absolutely nothing is changing. So we're going to have the same picture that we had. So all this stays exactly the same. That didn't change because you're taking the absolute value of a positive number. Right? Okay. Now, Dan, what was the other piece that you said?
Now with all the x, you just like flip it over the
Because if you put in a 2 or a negative 2, aren't you going to get the same answer? So whatever answers you got with the positive values are going to be exactly the same answers you get with the negative values. That's your answer. Whatever positive x's produced, y values, whatever y values were produced, are exactly the same y values that are going to be produced by negative x values, because you're taking the absolute value of x. This part of the picture is gone. It's replaced with this. Anything else on the quiz? Bailey?
Number 5.
What was number 5?
F of negative x.
F of negative x? Well, we just talked about that, Bailey. What does f of negative x do? That was one of our examples.
Well, sorry, f or the negative f of x.
Okay, well, we didn't talk about that one. But a negative is a reflection. What does that reflection accomplish? What does that do? Upside down. It turns your picture upside down. So it's going to take this picture, this was our original, and it's just going to move it upside down. Now I can't remember what the original was. Is that the upside down? Can't remember what the original was. Okay, Bailey? So a negative out here flips you across upside down, just turns you upside down. A negative in here reflects across the y-axis because you're changing the sign on x. It takes you across the y. Okay? So those practice problems, that's the type of thing that's going to be on tomorrow's quiz. Now, we need to look at last night's homework, which was exciting and fun.
Probably over last time.
Let's do a couple, and then I want to take some time and get started on tonight's homework, do a few with you, because there are quite a few, and I just want to make sure we work through a few of them together. Well, let's do a couple from last night. So who's got one from last night? Jamie? 17. Base of an isosceles triangle is half as long as the two equal sides. Okay, here's my isosceles triangle. Write the area of the triangle as a function of the length of the base. So I'm going to call that B. That's my variable. It says write it as a function of the length of the base. So my variable is going to be the length of the base. You can call X or something. And it says that is half as long as the two sides of the triangle. So what does that make the two sides of the triangle? If this is half as long as these, then what would these be? 2B. And I am going to write the area of the triangle. Okay, what's the formula for the area of a triangle? 1/2 base times height. Here's the height. Now, that would be a fine formula. There's absolutely nothing wrong with that, except it expresses area in terms of base and height. And our job is to express area only in terms of base. So I need to look at this right here for a minute. What kind of triangle is that? Just the shaded one. It's a right triangle. And what famous formula can I always apply to a right triangle? How long would this be? So 1/2 B squared plus H squared equals 2B squared. Would you agree with that?
Yes.
Now, I hope you kind of see where I'm going with this. What's wrong with this equation? Why don't I just use this one? This is a fine formula. Why don't I just use it? Because it's got an H in it that I'm not supposed to have. It's supposed to be all B's, right? So guess what I'm going to do with this equation? I'm going to solve for H. And then I'll take that and substitute it in. Yep. So this is going to be 1/4 B squared. And this is going to be 4B squared. So what does H squared equal? What's 4 minus 1/4? Oh, let's not use a mixed number. It's hard to take the square root of a mixed number. 3 3/4. What is that? 15/4? So what does H equal? The square root of 15 over 2 times B. Now, what am I going to do with that? Plug it in right here for H. And root 15 over 4B squared. Now, that's my area formula. Why is it okay? This one was not okay. Why is that okay? Because it's in terms of B. Jamie?
Well, I
because you didn't, your variable was this right here.
Well, then I used 1/4 x in the direction.
Yeah, that's okay, but what did the direction say? What was the variable supposed to represent in your final answer? In your final answer, the variable was supposed to represent the length of the base. What does your variable represent? Half the length of the base. Right. So what you did was absolutely right, nothing wrong with it, except that's not the way the problem was supposed to have been set up. They defined the variable for you. In the real world, you can define your own variables, but they defined it. They said use this as your x. Okay? So that's what happened. You did all the right stuff. You just had the wrong variable defined.
Can we do number 19, please?
19. A sphere is contained in a cube. So here's think of a ball inside of a box. Find the surface area of the cube. All right, let's just stop right here. What's the formula for the surface area of a cube? How many faces does a cube have? 6. Each one of them is a square, and the area of the square is, well, side squared. So really, our basic formula is just this, right? Where these are s's. Now let's see what variable I'm supposed to be using. Find the surface area of the cube as a function of the radius of the sphere. So I'm going to go ahead and leave those s's, but my variable that I'm supposed to be using is r, the radius of the sphere. What is the relationship between s and r? So s is 2 r's. Would you agree with that? Now this formula is perfectly okay, except it's done in terms of a side length. If I want to do it in terms of a radius, then what am I going to do with this right here? Plug it in. So I have 6 times 2r squared, which will be 6 times 4r squared, or 24r squared. So there's your formula in terms of the radius of the circle. Again, there is nothing wrong with this formula. They defined the variable though, and they said they want us to use r, not s, r. So we had to rework it.
Can we go over the box problem?
Yeah.
When I did,
Real quick.
okay.
And then I just really want to do a couple more of these problems, because I'm afraid we're going to have all kinds of issues if I don't. But we'll do our box problem, which was, how big was the paper?
20 by 18.
Okay, so here's our 20 by 18 paper. We're going to cut the corners out. Remember yesterday you made your own box? Thank you, by the way, for bringing them back filled with M&Ms. Maybe if I drop enough hints, I don't know. Okay. Now I want to build the biggest box that I can. So this problem's all about volume, length times width times height. But remember, the original paper was 20 long. But you cut these out, right? So how long is it now? This isn't 20 anymore. What is this now? 20 minus 2x. And similarly, you cut out these two, so this is now 18 minus 2x. So your length is 20 minus 2x. Your width is 18 minus 2x. And what's your height?
X.
Your height's x. Remember, we looked at that yesterday when we made our boxes. Okay, so let's talk about domain here. X has to be bigger than 0, and y has to be bigger than 0. Would you agree with that? That's domain and range. What does x stand for? These little cutouts? Can they be negative?
No.
No. So we gotta be bigger than 0. What does Y stand for? The volume. Can Y be negative? No. So both of them have to be bigger than 0. In other words, when you graph this, you're going to be graphing in quadrant 1. Now what about the limitation, the upper limitation on x? Think about your piece of paper. Think about what you are doing. Tearing a chunk off on this side and a chunk off on this side. What is the biggest chunk that you can tear off? 9. You can't tear off a chunk bigger than 9 because you only have 18. And if you take equal pieces off both sides, 9 is the biggest they could be. Everybody got that? So your domain is 0 to 9. So when I set up to graph this, x min, x max, y min. Now what are you going to put in for y max? Who knows? That's the question, right? What's the maximum volume? So we're just going to pick a number. And then when I graph it, I hope I see that. If I see this, what does that tell me? I didn't pick a big enough number, right? So I have to pick a bigger one until I can see the top of the hill. Then I'll do second calc and find my maximum. Now that will be an ordered pair. The question, I believe, was find the maximum volume. So when I look at this ordered pair, which coordinate will be my answer? Y. This will be the maximum volume.
My graph doesn't look like that. I don't know why.
Does it have the top of a hill?
No, it's like it's negative.
That's what mine looks like.
And I graphed it just.
Okay, now I'm going to come back here. Okay, you have Y max set at 10. Okay, think about, you have an 18 by 20 piece of paper.
Well, even when my
10
max
cents
was
over.
at like 50 is still conservative. How?
Hey, Max, what was it? You know the answer is?
She can find it, she's got the picture now. Anybody have an answer? What's the answer?
503.
What?
503 something.
503, so this is 503. And what was the X, Robert?
3.15.
3.9?
3.15.
3.15. And what does that 3.15 represent?
The size
How
of the
big
square.
the corners are? So if the question had been, find the dimensions of the box, that would mean length, width, and height. So then you would need the 3.15, right? And your dimensions would be 20 minus 6.3, and 18 minus 6.3, and 3.15 would be the dimensions of the box. Okay, we gotta get a couple of these problems in here, kids. A couple definitely I want to talk about. So open up your books to page 161. There are just a bunch of different kinds of problems here. And that is one of the reasons some of you aren't going to like this section, because they're all different. You have to think about each one. But I do want to give you a couple of pointers. I'd like to look at problem number 31. Actually, let's do 32. 32. These are the mixture problems. And you remember doing these in first year algebra? Yeah, you mix a percent solution and another percent solution and you end up with another percent solution, right? Or you mix so many pounds of peanuts with so many pounds of cashews and you get this mixture over here. When we do any type of mixture problem, whether we're mixing peanuts or acid solutions or money situations, regardless, you can't go wrong if you use a simple little format like this. Amount times percent plus amount times percent of the two things you're mixing together will equal amount times percent of the final solution. So here's how this works. I'm doing problem number 32. My percentages are 20 and 35. That's what I'm mixing together. And I'm going to end up with a 26% solution. So I'm mixing together a 20 and a 35, and I'm going to end up with a 26. Now, the only number that I know, other than the percentages, is what? The only amount I know is what? And what's the 25? That's the amount that I end up with, right? So the 25 is going to go right here. What?
Never mind.
Now I want you to think about this for a second. Pretend you got this big bucket here, and you have to end up with 25 liters in the bucket. So you're going to dump in some of this 20%, you're going to dump in some of this 35%. We don't know how much of either one of those, do we? So let's just call this one X. It doesn't matter. They didn't tell you. You can call either one X. It doesn't matter. But now keep in mind, here's my bucket. I got to end up with 25. So I dump in, let's say, 10. How much would I have to dump in of this kind?
15.
And how'd you get 15?
Minus the X.
You took 25 minus 10, right? So if I dump in X, how much of the other will I have to dump in?
25 minus X.
25 minus X. And there's your equation. Now it's just a regular equation. You're going to go through and solve it just like always. Okay? I don't want to take time to solve it. You can do that on your own. Let's try number 38. This is a variation of the same thing, but it's an interest problem. So you'll remember that simple interest is I equals PRT. Do you remember what all these letters stand for? What does I stand for?
Interest.
That's how much you end up with, yeah. And P stands for principal. And what do we mean by principal? That's the starting amount. And this is the rate. And this is the time in years, right? Okay. So for this particular problem, we're doing number 38. It says total annual interest. What does that tell me about my problem? T is 1. Okay, so the T is 1. He's got 2 investments that are going to end up giving him $900. Would you agree with that? What's the percentage on this one? Remember, we're doing PRT, but T is 1. So what's the percentage on this one? 7%. What's the percentage on this one? 8.5%. Now, how much money does he have to invest?
12,000.
And he's putting part of it here and part of it here, right?
12,000.
But we have no idea how he divided it up. So we'll just call this X. How much did he put at the 8.5% then? If he put X at 7%.
12,000 minus.
12,000 minus X. So it's very much like a mixture problem in structure. The difference is you actually have an amount you know you're ending up with. So 7% X dollars, 8.5% the rest, 12,000 minus X, has to add up to 900. Technically, there's a 1 next to each of these, but you don't need to include that because it's a 1. If this were for 2 years, you'd have to put a 2 in there. That's not too bad. That's manageable. Okay, let's try, how about 26. All these are assigned problems, by the way, folks. Okay, what about 26? What do you think?
$560 for your final thing.
Okay, so tell me what your,
You said everything equal to 560?
What would it be? T was rate times time.
okay. This is gonna be a rate times time problem, I bet.
We're trying to find time, so we solve for T.
Okay,
That'd be T equals distance over rate.
okay. So our answer, what we're looking for, it says what is the total time they spent driving on the highway, on local highways. So should we let, well, I don't know, you tell me, I don't know. What do you want to let, what, okay, where we go from
45
here?
is the rate.
What?
45 miles an hour.
Is one of the rates. 45 is the local rate. And 55 is the, what, interstate rate? Could we, I'll go ahead. What do you think? We got some good stuff up here. I'm just not sure where we're going, but let's see if we can figure it out.
What, 516 for D?
Uh-huh. Well, be careful. 560 is the, isn't that the total?
Yeah. So, maybe half the...
If we did the distance on local plus the distance on interstate, that should add up to 560. Would you agree with that? And how do we find distance? Rate times time. So on the local highways, the rate is 45, and the time is I don't know what. I'm gonna let time be the local time on the highway, the local highways, the time on the local highways. So I don't know how long that is, so I'll call it T, but distance equals rate times time. So the distance on the local highways is 45 times T. Agreed?
Yes.
Now, what's the distance on the interstate? Well, it's rate times time, so that'll be 55 times time. Look back at the problem, what does it tell you? They spent 2 more hours on the interstate than they did on the local. So we said T was local. So what would interstate be?
T plus 2.
T plus, what,
T plus
someone say
2.
2T? Not
plus
2T.
2.
T plus 2? Distance is rate times time. So we take the rate times the time on the local, the rate times the time on the interstate, and that has to add up to 560. Would you agree with that? So I think that is a nice little equation to use for that problem. And then you can solve it. All right, let's do, that's about all the time we have. So tonight, there's no word problems on tomorrow's quiz, but they're in tonight's homework. So give them your best shot, we'll talk about it tomorrow. Tomorrow, after our quiz, we start reviewing. So we'll review tomorrow, Friday, and Monday, and our test is Tuesday. Everybody clear on that? Yes, we will go over our last test as soon as we get everybody taking it.